The next thing we're going to have a look at before we exit ZBrush or ZBrush is to how to export displacement maps. In a RenderMan based pipeline, you'll have the ability to use vector displacement maps, which can displace in X, Y, and Z directions, and scalar displacement maps, which will displace outwards from the normal of the base geometry. Displacement maps are really helpful because they allow you to basically use the low polygon geometry, add a RenderMan subdivision scheme onto it, and then use the displacement of the high resolution geometry over the top. However, there are a few limitations. If you're using geometry that's too low in resolution, it's missing geometric detail, like with things like holes through these gaps and major surface detail on the shape, displacement isn't going to model the geometry for you. It's just going to enhance the geometry that's already there. So keep that in mind when you're using displacement maps. It's not a silver bullet that enables you to create basically like a spaceship out of a plane. It's still a way to enhance the modeling and the surfaces that are already in your scene. But it can do it very accurately and very well. So let's have a look at the displacement settings. Now, to export displacement, we're going to be using, first thing you need to do is figure out what subdivision level you're going to be using in your 3D animation package. Now, I initially had subdivision level 1 in Maya, and then had the displacement on that. But what I found was that it was lacking some of the details that you were getting from higher subdivision levels. Now, it's a trade-off between performance and detail. And what I found was actually that subdivision level 4 and subdivision level 3 were the best subdiv levels for using all this photo scan data in Maya when you're lighting, animating, and doing effects. So on subdivision level 4, you're looking at 1 million points, and in the file explorer, if we have a look at the different subdiv levels of this tree root geometry, we have a 2 megabyte level 1 detail, a 10 megabyte level 2 detail, a 43 megabyte level 3 detail, and 178 megabyte level 4 detail. Now, the 178 megabytes, if you've got 10 or 20 pieces of geometry in the scene, that's still only going to be around 2 gig. So this is actually a good level of detail to load into a 3D animation package. Whereas subdiv level 5 at 736 megs is extremely large. It's almost as big as your entire scene that you want to be working with in the viewport. So being able to go into this second from the top subdiv level is great because it gives you a lot of detail to work with in the 3D scene without blowing out the file size of the models that you're using. So let's assume that we're using subdivision level 4 in our scene, which is going to allow us to run characters on the scene, and you can see it's still very interactive and lightweight to use, which is the same performance that you'll get in Maya using Viewport 2.0. So if we want to bake displacement from subdivision level 4, we'll be wanting to use the displacement from subdivision level 5 and bake that onto subdiv level 4. So the way to do that, now that we've decided which levels we're using, the way to do that is using the multi-map exporter plugin. So if you go up to the Z plugin tab and hit the button on the top left hand side and expand the multi-map exporter, we've got all these different options on here. We've got cavity map, ambient occlusion, texture from polypaint, normal, vector displacement, and displacement. The one we're going to be using for this training is displacement. Now inside the export options, we've got, first of all, we've got the map size, and this is where you can set the resolution of the displacement map that you're using. For our purposes, we're going to use a 8K map, which is 8192 resolution. And then in the export options, we need to have a look at some of these settings because it's super important for what we're doing. The first setting is subdiv level. So we've got subdiv level 4. Subdiv level 4 in the top panel here, and we're going to leave that at level 4. Now the next thing is we've got the adaptive button pushed on there. We've got 32-bit and we've got EXR. EXRs are linear images which don't have sRGB color space baked into them. They basically have all the colors from 0 to 1 in maths that is able to go infinitely up and infinitely down in terms of values. So when you save EXR files with displacement, the height of the displacement is stored as a mathematically correct number rather than as kind of like a JPEG kind of image data. So if this is 0.4 extruded off the surface, and this is minus 0.02 pushed into the surface, it's going to store that data as very mathematically accurate numerical data. So this goes beyond being just a simple image file. It's actually a data file stored in an EXR file, which has the displacement distance stored as maths in the EXR channel. Once you're ready to create the displacement map, all you need to do is create all maps and type in the tree roots A1 displacement and press save. That's going to generate the displacement map from the model. And there's also a button here to export the model if you want to do that as well. So if you just let that project the detail and the graphics onto that texture, we can have a look at it and you can see what the displacement map looks like. So here's an example of a displacement map that's open in Nuke that's been adjusted so that you can see you can actually see the contrast and the detail in the EXR image. Now this one's been sort of color corrected to get more contrast out of the image, but don't be surprised if the images you save out don't have any information in them that you can see visually, because they're not really necessarily a kind of like an image or a picture. They're more a flat mathematical layout of the surface relief of the object. So you can see here as I hover over in the red channel down here, it's got all the depth and height information, and basically where it's light it extrudes up, and where it's dark it extrudes down at render time. So I'll close that down. Now the next thing we're going to be having a look at is how to now go back into Agisoft Photoscan and bake our texture maps onto our super duper nice model that we've made. So if we open the scene that we were just working on, we've got our high resolution tree roots that we exported to ZBrush that has excellent detail in it, but incorrect topology for a visual effects or games pipeline. So what we needed to do was retopologize the model and then basically bring it back, and then we bring it back into Photoscan and reproject the textures back onto it. Now, the reason why we do this, just to repeat myself, so that you understand, is if you use this model textured in production, it's going to cause you problems down the line. So for example, in the texturing department, it's going to cause problems because they can't unwrap the model. In the rendering department, it's going to cause problems in the lighting department, because they're going to have trouble adding displacement, subdividing the model, putting effects elements into it that might need to deform the model or break it apart. It's not just all about you in your section. You really need to fit within the pipeline of other divisions that are down the line that need to work with assets. That's why it needs to be quad polygons and have different levels of detail and be easy to manage. Now, in terms of the texture maps, the texturing and the way that it can create its own texturing on these models inside Agisoft Photoscan is just totally amazing and awesome. The way that it's able to build these triangulated meshes and texture them, even though they're so complicated. So totally my hat goes off to them for being able to do that. But it's much better to have a UV mapped model with different levels of detail. So what we're going to do is now import our model, and it's going to go snap right into position here. So we'll go workflow, tools, import mesh. So what this will do is this is going to import our quad based model that we just created in ZBrush. It's going to completely delete or get rid of the high resolution Agisoft Photoscan generated mesh, and it's going to re-import the mesh that we've got from ZBrush using whatever UV maps that mesh has. So if we go into import mesh, and then we go into effects PhD training levels of detail. So we now have 5 levels of detail that we can choose to texture this mesh, and I'm going to pick subdivision level 3. It's got a coordinate system in here. I'm going to press OK, and it's going to import this mesh, which is only about 50 megabytes. Now, this mesh has the identical UV maps to the ultra high resolution mesh. So it's easier for you, Agisoft Photoscan, to my understanding, it's faster to process, and it will create the texture maps better using a slightly lower polygon mesh that you've brought into the software, as the UV maps for this mesh and the high resolution mesh match each other. If you use a lower resolution mesh, you can get speed ups of, from 2 times to 100 times speed up of creating texture maps for meshes, depending on what resolution of mesh you have in here. So this mesh is done with a single texture. So when we go up to texture it, we've got different options there. So if we go into tools, workflow, build texture, this is the options we have for texture mapping. In the mapping mode, these are the options that it has before you have a UV mapped model. It'll have generic, orthophoto, adaptive orthophoto, spherical, and single camera. They will basically map the geometry as best they can using shredded UVs or using a single camera to map it downwards onto the ground. Generic is really good if you're using just Agisoft Photoscan and no ZBrush. But for us, we definitely want keep UVs, because we've gone to the trouble of generating our UVs in ZBrush. The blending mode, you've got different blending modes in here. We've got mosaic, which gets the cameras and uses the camera which is closest to that piece of the model and basically projects the camera down onto the model from that point. It's important when using mosaic, though, that the cameras have got matching color, matching exposure, and matching depth of field, so that when you project them on, you don't have some parts of the timber or the model looking like they're out of focus, and other parts looking like they're sharp, and other parts looking brown, and other parts looking red. You really need the cameras to be calibrated and color matched the images so that you're able to get the right effect. Average is going to average out all the pixels across the image and blend them together and kind of blur them together. And that is going to give you a more uniform color, but it's also going to give you a less sharp overall image. But by all means, try mosaic and average and see what kind of effects you get. Now for the texture size, for our use, which is going to be in a RenderMan RIS end result, we're going to use a 16K texture. You can also use a 32K texture if you've got a powerful workstation, or you can use an 8K texture if you're using a laptop. It's important to note that the texture limit of Unreal Engine 4 is 8K in the version that I use, which is the latest version that they have off the internet, is 8K texture maps. So if you're using these assets in Unreal Engine, you'll be wanting to set your texture size to 8K, or at least render it at 6K and then down res it in Photoshop. Enable color correction, that sounds very positive, but we actually want to leave that off, because that is going to change the textures as it's processing them, and we want to keep the color the same. So we're going to press OK on that, and now it's going to blend our textures and build our textures on the model. So what's great about this is it's going to give us, the better the UV maps are and the higher resolution the texture, the sharper detail it's going to be able to assemble from all these high resolution DSLR stills that we've created to create our model. So the better your UV maps are, it really, really, really pays off in this stage when you go to generate texture maps in Agisoft Photoscan. I've sometimes seen on models twice as much detail come out of the textures from better UV maps being created in ZBrush for different complicated tree roots and rocks and different surfaces. So definitely breaking up your UV maps using polygroups and setting it all up really properly has massive payoffs when you come to the texturing stage, where you're reprojecting the textures onto your models. So let's see how that processes, and then we'll have a look at the finished result. So once it's finished building our texture maps, we get this super, super nice textured model here, which is even better and more detailed than the original model that we got out of the base geometry. So you can see here we've got extremely sharp, accurate textures wrapped around that geometry, which just has incredible detail, even in this OpenGL preview. So when you actually render this in RenderMan or in Arnold, you'll get even more detail out of these textures, because this is just the display version of these textures that's loading on the graphics card. So you get here, just get awesome detail on all the rocks, on all the wood surfaces and everything. And it's all happened automatically. I haven't had to go in and paint these in Substance Designer or in Mari or in Photoshop. It's all done automatically using just the photographs of the scene that I've got. So basically, that's done a really good job, and I'm really happy with the texturing work that has wrapped around that model, at least at this initial stage, after a couple of hours of playing with this scene. So the next thing we want to do is export these textures so that we can edit them in Photoshop. So the way to do that is you go File, Export Model, and we're going to put this into our level of detail folder, and we're going to call this textured textured tree roots A1 underscore textured, and we'll save that. Now in here we've got export texture. We want to save this as a TIFF file. You can also save it as an EXR if you want to use a linear format, and then press OK, and it'll save it out of its own format into an image format. So that's how you can reproject textures or recalculate textures using a ZBrush model that you've imported back into PhotoScan after you've edited it. And keep in mind, these ZBrush models, you can edit them, you can manipulate them, you can clean them up, you can change them, you can do all kinds of things to them that enable you to add in lots of details like all this moss and different things, and then reproject the textures over the top back in this software. So it's very flexible, the way that it's able to have models come in and out of the software. Now let's have a look at how we can view this texture in Photoshop so that we can edit it or adjust it or zoom into it and make changes to it, because that's really important. With one of the great advantages of UV mapping this in ZBrush is we're able to now edit the texture a lot more easily because it's been unwrapped into a flat surface that's easy to work with. So let's have a look at that now in Photoshop. Out of interest, here's what the average blending mode looks like on the same model, just so you can see what it compare the two. If you have a look at this, you can see that there's more consistent color and texture across the model, with less of a kind of patchwork effect where it fits the different textures together. However, you get a kind of softer detail in these sharp areas like rocks and leaves and moss and things like that, where there's individual photos being blended together over the top of each other. So I really like this this blending mode. It gives a really soft, uniform feeling for these complicated objects at the expense of a little bit of sharpness. So that could be helpful if you maybe haven't got ideal shooting conditions and you've got different colors on your cameras or things like that. In any case, let's have a look at Photoshop, and we'll open up our texture map which we exported. Now this is going to be located in the training folder. So this is our texture map that we just created in PhotoScan, and if we zoom into it, like this section here, we can see that going to the effort of laying out those UVs correctly has really paid off, because this is so much easier to edit than the crazy little splinters of texture that we had before. You can see here that this is very easy to figure out. We've basically got the roots of the tree here all flattened out with leaves beside it, so we can easily paint on this and adjust it as necessary. For example, if we want to remove the leaves from this texture, if we don't want those in there, we can easily go in with like a clone brush and increase our brush size, and we can easily just paint those out, and then when it renders, it'll just have the sort of generic underwater color here that we've got on it, instead of having leaves in the actual texture of the roots. And then you could put leaves on with with texture mapped cards in RenderMan that have displacement on it, so that you can easily get the foliage on one section of geometry and keep the tree roots on another. The other thing that you can do with these texture maps that's very helpful is you can globally select different parts of the image and create contrast or saturation adjustments. So for ease of being able to see this, I'm going to just drop a black paint bucket underneath this. It's going to take a little while because we're dealing with a 16K texture here. And while I've got this whole image open, I'm going to go up to put a color correction layer on here, and I'm going to go up to color balance. Now, if you're working with these textures, and when you render them, you're finding that they're a little bit not saturated enough, or you want to basically edit the color in Photoshop, you can go up to this color balance thing, and you can pull the blue out of these textures, or you can pull a cyan out, which is one of the things that you sometimes have to do because of the skylight spilling onto the textures. So basically what you have now is you have a different color version of your original base texture. So if we have a look at the difference there, we can see that these rocks here are much warmer when we add this color balance on, and we're losing that blue lighting that's coming across them, which is actually from the sky that we're getting. So that's one way that you can color correct these textures and edit them much easier in Photoshop than you could with those shredded UVs that you get out of the default Agisoft Photoscan texture maps. The other thing you can do is obviously paint completely new textures. You can get stills of rocks and roots and overlay them over the top of these textures and replace the textures. You can repair bits of the textures that might be missing, or you might have blurry parts of them, or holes, or different things that you want to fix. It just basically becomes a much easier process to do edits and to do adjustments using this very simple, flat, easy to understand, artist friendly 2D layout done from the ZBrush UV maps. In the next class, we're going to be having a look at creating trees, and in particular this tree, which I've given you the data sets for in Agisoft Photoscan. Trees are a little bit different to flat objects because you've also got vertical as well as horizontal detail to keep in mind, and things like leaves and background trees and background leaves that you need to isolate and cut out of the scene. So let's have a look at this. We're going to be having a look at this scene and seeing how we can edit it and get the best results from our 3D recreation.